Hello and welcome to the first proper video in this series following along the development of Socks, a simple walking game. In this video we'll set up our backend server, i.e. the service that will store and modify the player's eggs and socks collection, as well as interact with Fitbit and Google Fit to get walking information. After we've set up the Spring Boot application, we'll create two endpoints, a /eggs endpoint, which just returns a list of eggs, which I'll demo here. So I've got the application itself running in IntelliJ, and if I curl the eggs endpoint, we'll see it prints out a list of the player's eggs with their details, for example, the distance walked and the total distance required to hatch. The other endpoint that I've created is the walk endpoint, which simulates a 1.5K walk, which will essentially up this distance walked on the first egg to 2.5. So it gives back some information saying what event has happened, and in this case it's just been a walked event rather than a hatched event, and it's increased the distance of the walked distance of that egg to 2.5, which if we call the eggs endpoint again, we should see that that's gone up to 2.5. Now if we continue to walk this egg, we should eventually get it to hatch when the distance walked equals the distance total. At the moment, the egg essentially just disappears, but in the future it will hatch into a sock or a creature or something like that. So if we go back to the eggs endpoint, we'll see that we now only have 2 eggs rather than 3 because that other egg hatched. The easiest way to get started with Spring Boot is to use the Spring Initializer tool, which is just a website that will allow you to create a Java project essentially with Spring Boot, with all of the Spring Boot dependencies set up. So to start with, we'll just, for the most part, keep everything as default, except we'll switch over to Gradle. And Gradle and Maven are just these build tools, and I would say that Gradle's kind of the more modern version, maybe a bit more complicated, but not really that complicated. We'll stick with the 2.7.1 version of Spring Boot and then enter some of the product details. So just have the group as just IO mini builds. And we call the application Socks API. And we'll use Java 11 for now, just because that's what I've got installed on my machine. But it shouldn't really be any problem to switch to different versions of Java if we wish to. And for now, the only dependency we really care about is just the Spring Web, which just allows us to easily set up a web application essentially. And then we can click generate, and that will download, and that will create and download a zip that contains the project. And if we unzip that and open it in our preferred IDE, for example IntelliJ, we'll get a fairly bare bones Spring Boot application, which if we start running, which we can do by running the boot run task, we see that the application itself starts and it's listening on port 8080. But at the moment we don't have any endpoints set up, so if we just curl that endpoint, i.e. localhost 8080, we should get a 404. So as expected, we get a 404, which means not found. To start with, we'll just add a sort of /eggs endpoint just to get something back from the Spring Boot application. And to do that, we have to add a controller, which is just a class that's been annotated in a particular way so that Spring identifies it as a class that contains methods that are mapped to endpoints. So if we create our egg controller, we'll add a few methods to it. So let's create our egg controller. We'll put it in the package controllers or controller and give the class itself a name of egg controller for the moment. And first thing we need to do is add the Spring annotation REST controller, which allows Spring to identify this class as a controller. So for the moment, we'll just add a method that returns a string just so that we can see something happening. And for Spring to identify this method itself as an endpoint, we need to use a sort of one of the request mapping annotations. And in this case, we'll just use the get mapping and just pass in /eggs as the endpoint. So what this means is Spring will call this method if it receives a request to the eggs endpoint that is a get request. So in HTTP you have get, post, delete, patch, and so on. The get, unsurprisingly, is just used for getting resources, so it's an appropriate method for this particular endpoint. So if we restart our application, and then do a similar curl command, but instead of just to nothing, we do to eggs, we get eggs, which is just this string right here. Yeah. As you may have guessed, we don't actually want our endpoint to return just the string eggs. We want it to actually return some eggs themselves, i.e. information about how far a particular egg has been walked and how far it needs to carry on walking, possibly any items applied, things like that. So to do that, we'll create a new class called egg. And this class will have a few fields that describe it. In this case, an ID and two decimals. One is how far it's walked, and the other is the total distance it's got to walk. And the fourth is an item, so whether or not this egg happens to have an item applied, like some kind of hatching acceleration item. And then we just create a constructor that takes in all of those variables and a collection of getters for each of those fields. And then back in our controller, we can now change this to, instead of just returning a string, we'll return a list of eggs. And bring in those imports that we need. And just return a list of, for the moment we just return one egg. Just give it a random ID. And yeah, big decimal of 1 is fine for the moment. So it's walked 1 kilometer, say, out of a total of 10, and it's got no item applied. So now if we restart our application and perform the same curl, we should see a list of these egg objects with the details that we've supplied up here. So it's got some random ID, distance walked, and the total distance. So obviously we don't just want to return a static list of eggs. We want to, in the future anyway, store the eggs in some kind of database and then retrieve them for each individual user. So for the moment, we'll create a simple service that will have a getEggs method that will return the list of eggs, and it'll kind of just manage all of the logic of kind of dealing with lists of eggs. So when the user walks some distance, it'll alter the eggs in some way so that they hatch. So we'll create our egg service class in the service package and add a getEggs method. For the moment, we'll just have a variable in this class that is just a list of the eggs, and this is just returned by our getEggs method. But eventually this will be read from the database. Now in our controller, we can make use of this service to get all of the eggs that the user has, that the player has. We'll add the egg service to our controller, and if we have that provided in the constructor, Spring will search for and find egg service and provide it to us upon instantiation, as long as we have annotated the egg service with the service annotation. So this annotation means that Spring Boot will search for it and it'll be part of its sort of dependency injection system. So it will find this and instantiate it and then provide it to our egg controller in the constructor, and then finally we can use it in our getEggs method to just simply egg service getEggs. And now if we restart our application and make the curl again, we should see a sort of similar result, but 3 eggs instead of just 1, and it's reading them from the service that we created. So you see we've got 3 eggs. So we've successfully got our backend returning a collection of eggs. So the next thing we'd like to do is add another endpoint that's a post endpoint instead of a get endpoint that will walk the eggs, i.e. move them closer to hatching or hatch them if that's if they've reached the total distance essentially. So to do that, we'll start by adding our endpoint, which is now a post endpoint, hence the post mapping. And for the moment, we just call the endpoint /walk, and we'll have the result as a list of egg events, which is a class that we'll create in a second. And we'll call the endpoint on the egg service called walk, which we'll create in a second. And for the moment, we'll just pass in a big decimal of 1.5 as the distance it's walked. But in the future, we'll want to get this distance from some kind of step provider or walking provider, for example, Fitbit or Google Fit. So we'll create this egg event in our model class, and this will only really have 2 fields. So the type of the event, i.e. whether it's a hatched event or just a simple like walked a little bit more event, and we'll represent that using an enum, which is essentially just an object that has a limited number of values. So now that we have the event type enum, we can set up the fields on this class, i.e. the type and also the egg that's actually changing. And we make both of these fields final, and add the constructor and add some getters for those fields. And now comes the relatively substantial part of writing this walk method. So as we were saying in the controller, this walk method is going to return us a list of egg events, i.e. whether eggs have changed or hatched, and it's going to take in some distance as a big decimal. So this is the distance that the player has walked. So the first thing we want to do is get the current list of eggs, which we can just use our getEggs method to get that. And then we'll create a list of the egg events that we'll build as we loop through the distance. So we'll keep track of the distance left in a variable called distance left, and that will start with start at distance, and then we'll want to essentially loop through while the distance left is greater than 0, and we also still have eggs to hatch essentially. So we're in our while, we'll add this clause, which essentially is what I said: the distance left compared to 0 is greater than 0, i.e. in a less verbose language you'd probably just write simply that, but that's not the Java way, unfortunately. And likewise this one's just simply is the eggs list empty, and then negated, so is it not empty. So since we know that the egg list is not empty, we can just get the first element from it without having to worry about an index out of bounds exception or anything like that. And then we want to calculate the distance to hatch, i.e. how much distance this egg needs to get to be hatched. And we can just calculate that using the difference between the total and how far they've already walked, how far the egg has already walked. So if the distance to hatched is less than the distance left, i.e. we've got enough distance less than or equal to it, then we can hatch the egg, add a egg event, and also take the distance down by distance to hatch. And we also need to add a setter to our egg class as well. So at the moment this field here, which is the one that we want to change, is final, so we'll just remove the final here and add a setter just here, so that now we can update this distance walked field. And then we want to add an event that just notifies the caller that this egg has hatched. And then just take off the distance hatched. And then, so this is the hatched case, but if we didn't have enough distance to hatch, then it's very similar to this, so we'll just copy and paste that, but instead of saying the distance to the total distance, it's simply adding on the distance that we had left. And naturally we have to use the and add method. So this is similar, but instead of hatched, it's now just walked. And because we're in this clause, we don't actually have any distance left at all, so we can just return 0. We can just set the distance left to be 0. And finally, we actually want to return the events that have happened during this process. And with any luck, that would be it for this. And now if we restart our application and call the walk endpoint, we should see the eggs progressively increase their walked distance, or at least the first one. One last thing we actually want to do is remove the egg from our eggs list when it hatches. So we'll remove this for the moment and simply just do eggs remove the egg that we're currently walking, if you like. So now if we restart the application, we should be able to call the /walk endpoint, and that will walk these eggs so that we'll see the walk distance increase. So we just start with just getting the eggs as normal. And then if we call walk, we also need to, so this new method is a post method, so we have to add the method like that. And we see that this particular egg was walked 1.5 kilometers. Hence it's gone from 1 to 2.5. And if we again just get, we then just get all of the eggs again, we'll see that 2.5 is there. And if we keep walking, we should eventually get to the point where it ticks over to the point where it's removed one of the eggs. So now we've only got 2 eggs. So it looks like this is functioning as expected, i.e. it's consuming all of the distance and hatching eggs, producing events, and finally removing the eggs as well as we go along. So as mentioned up here, like this will eventually be, instead of just working on some field in the class, everything will be read to and saved to a database, but that's like a future task. This is sort of the basic logic will actually be the same, just with some surrounding methods to write to the database. With our egg controller set up and ready to go, let's finish off by adding some tests for the controller and also our egg service. So if we're in IntelliJ, you can just press Ctrl+Shift+T and that will automatically just create a test for us. And what we essentially want this test to do is spin up a test version of our application and then check that when we make a request to the eggs endpoint, it calls our egg service get eggs method and then returns the eggs. And likewise, when we post to this walk endpoint, we want to check that it calls the walk service and then returns the list of events that returns. Luckily, Spring Boot makes this fairly easy with a bunch of annotations that firstly spin up a test version of the Spring Boot application, and that's the @SpringBoot test annotation. So all of these annotations come from the Spring Boot starter test package, which is just added by default by the Spring Initializer. And the second very handy annotation we want is the auto-configure mockmvc. And what that does is provide a mockmvc to our class, to our test, which is essentially the entry point to our test version of the Spring Boot application. So this application we can make our get and post requests to. And the final thing that's particularly useful about the Spring Boot starter test package is the mock bean annotation, which behind the scenes uses Mockito, which is a mocking framework, to essentially provide us with a version of some particular class or service that we can force to return particular results. For example, we can force our egg service to return a set number of eggs or a set collection of eggs for the purposes of our test. So let's start by creating our first test case, and in JUnit all of the tests just have to be annotated with @test, and then you should see in IntelliJ at least the green run button appear. So for this very first test, we're just going to check that the eggs request, i.e. the request to the eggs endpoint, simply gets the eggs from the egg service. So we'll start by just creating a dummy egg, and then using Mockito, we'll make it so that our mock version of our egg service up here returns a list containing that egg whenever the application calls the get eggs endpoint. And then finally we just need to use our mock MVC to perform the get on the eggs endpoint. What this is doing is making a get request to the eggs endpoint and also setting up the content type header. And this mock MVC allows us to also set a bunch of expectations. For example, we expect the status to be returned is OK, i.e. 200. And we also expect a few things from the JSON result that's returned. For example, we expect it to be a list where the first entry has all of these fields set. So the ID just simply exists. The distance walked is 2.5, which is the number up here. The distance total is 10, which again is the number up here. And finally, this null matches this, or it simply doesn't exist. And because we are only returning the one egg, we expect it to not have a second element in the list. And then finally, we want to just check or verify that our egg service method was called, at least for one time. So now if we run this method, run this test, we'll hopefully get a green tick. And that has confirmed that with our mocked egg service, a call to the eggs endpoint returns the expected egg in a list with just one value, and it definitely called our egg service as well. So for the second test, we're going to test the behavior of our walk request, which is very similar, but instead of a get, it will be a push, and instead of calling the get eggs, it will be calling the walk method. So we'll start in a very similar way to the previous one. We'll just set up this dummy egg that we can use in our data, that we can use as a result of our call to walk. And we just have we mock up our egg service so that when the walk method is called, it just returns a list containing this one egg that was hatched. And as above, we'll just perform a post on the walk endpoint and add a load of expectations. In particular, that the type is hatched because the egg event was a hatch event, and the egg exists in the response, and the egg ID exists, as well as a bunch of other information, but it's kind of enough just to assert that the ID exists. And finally, we want to assert that the walk method was called. Now if we run this, we should get another green tick. A minor tidy up, but I believe that we can get rid of this since we're not actually providing any content in the body of either of these requests. So we'll just give that a run, and hopefully they're both passed still. Brilliant. So we've written a reasonable test for our controller, so we want to just go a step down and also write a test for our egg service itself. So again, we just use the Control-Shift-T, create a test in the usual package. And luckily this test is going to be a bit simpler, so it's just essentially testing a plain old object with a few methods on it. There's no Spring Boot setup or anything like that that we need to do. So we can simply instantiate an egg service and then call it directly and just manipulate it essentially. So we'll start by adding a test of the getEggs method. So we just say getEggs returns the eggs. And to test that, we simply just get the eggs from our egg service and then essentially do a load of assertions on it to make sure it's got the properties that we expect. For example, with our egg service as it currently is, we're just going to expect that it has 3 eggs in it, like that. And we're going to expect that, or assert that, all of the IDs are not null, and for all of the eggs, the get total distance is 10. So these seem a bit arbitrary, and they kind of are at the moment because they're just from our list. But in the future, we'll have this coming from our database, and we'll be able to, instead of having a fixed set of eggs, it will mock whatever the egg service uses to read from the database and then make assertions on that. And we'd probably make it so that the mocked version of this database interaction just returns this, so that we barely have to change the test when we come about to testing it in the database with the database implementation. And then we also want to add a load of assertions of the current distance walked. So for the first egg, it's just 1, and for the other 2, it's currently set to 0. And now for the test of the walk method, which is a little bit more complicated. So start off very similar, where we just call the walk method on our egg service above, and we're passing a distance of 10. And the reason we're passing is in 10 is so that the first egg will hatch and the second egg will be altered slightly, and we'll be able to check that with some asserts. So after the walk has run, we should find that the eggs have changed, so we can get those from the egg service. So as I was saying, we'll expect 2 events. The first one is that the egg hatched, and the second one is that the egg walked a little bit further, or the distance walked increased a little bit. We have a similar asserts for the remaining eggs, if you like. So we should have the case, it should be the case that 2 eggs are left, and the first one now has a walked distance of 1 because there was a leftover bit from the hatching of the first one, and the distance walked of the final egg shouldn't have changed because that was all sort of used up in the first egg, or first and second egg. First and second eggs. So now if we run this, we'll hopefully get a good green tick. So the nice thing about just having sort of tests from the start is if we ever add additional functionality or we find a bug in our walking method, for example, we can just copy this test and set it up in a particular way that simulates our scenario where the bug was happening and write a test that hopefully fails and then go and change the code to fix it, and the test should now fail. So it's sort of a very test-driven approach to fixing bugs. So we now have a sort of very basic Spring Boot application that returns our eggs and also walks eggs. At the moment, obviously the eggs just hatch and essentially disappear, but in the future they'll return, you know, a sock or a creature. But that's for another day. So in the next episode, we're gonna essentially set up our Flutter application, and I would like it to call this method and then possibly just for the moment display a very simple list. So we'll get to create a HTTP client in our Flutter application and also just use the list view widget to list the eggs. Hopefully you've enjoyed this quick intro to Spring Boot and you sort of have an idea of what Spring Boot is and how to write simple applications using it. Thanks for watching.